Kia ora. My name's Justin Hodgkiss. I'm a Professor of Chemistry at Herenga, Waka, Victoria University of Wellington, and I'm co-director of the McDiarmid Institute for Advanced Materials and Nanotechnology. My research team here, a team of chemists and physicists, is working on technology for tomorrow's solar photovoltaic cells. Now this year will see us capture more of our energy needs from sunlight than ever before. The same was actually true last year and the year before that. And I hope to convince you that the exponential growth of installed solar PV or photovoltaics will continue to be fueled by new technologies. Now the Earth receives as much energy from the sun in just 1 hour as we use in an entire year. We only need to capture a small fraction of that to satisfy our needs. Now Thomas Edison and Henry Ford spoke about, back in the 1930s, they spoke about putting their money on solar energy before oil and coal ran out. And actually, the history of solar energy goes way back further than that, a few billion years in fact, with the evolution of photosynthesis. But unfortunately, photosynthesis will not give us the 30 terawatts needed to power our planet. And that's because photosynthesis is only 0.3% efficient at converting solar power into chemical fuels. And that's just because plants only capture the energy that they need to survive. Now, a better, or at least a more energy efficient way to capture energy from the sun is with a solar photovoltaic, or PV cell, which can have power conversion efficiencies over 100 times higher than plants do. A solar PV needs a semiconductor, such as silicon, where light interacts with electrons to induce a voltage, and then the electrons flow around a circuit as a current. And we know that voltage times current gives you electric power. Now the installed PV capacity is doubling about every 2 years. And this growth is outstripping even the most optimistic predictions. And it's obeying exponential scaling laws seen in many technologies such as computers. Now underlying this growth is an exponentially falling price of photovoltaics. The more you make, the cheaper it is to make, and so there's more demand and the virtuous cycle continues. And we can expect solar PV systems to keep getting better as scientists develop new types of PV cells that could replace silicon. The next generation PV cells might look more like this. This is a polymer technology that we're developing here at Te Herenga Waka, Victoria University of Wellington and in the McDiarmid Institute. The exciting thing about these next generation PV cells, and the reason that they may fuel the next PV revolution, is that they're really lightweight, they're flexible, and they can be printed. And therefore large areas can be churned out at very low cost and for entirely new applications. Their efficiencies are rapidly approaching that of silicon, which is the technology that you see on today's rooftops. Now the active semiconducting polymers in these photovoltaic cells are spread so thinly that 1 kilogram will spread over about 5,000 square meters. And what we can do is we can use chemistry to enhance the properties. We can tune the color, we can tune the conductivity, and we can design them to have much more environmentally friendly manufacturing. So this is one way that we can expect material science to offer new technological possibilities for an economically and environmentally sustainable future. And this is also an example of the type of area of technological development where we expect tomorrow's jobs to be for our future graduates. New Zealand's tech industry is growing at 10% year on year, and it has been for quite some time, but it's now at the point that by the time that today's incoming students graduate, the tech industry will be New Zealand's #1 export industry, ahead of tourism. Even without COVID, that was going to be the case, and ahead of dairy. And this is a great thing for our sustainable, environmentally sustainable future, because high tech has a low environmental footprint. So the types of jobs that our chemistry and physics graduates might find themselves going into in New Zealand are things like urban mining. So a startup company in New Zealand called Mint Innovation is taking e-waste, ground up computers, and extracting precious metals like gold from them. Or Humblebee is making bioplastics using the genetic secrets of a certain types of bee that makes a very strong plastic. So whether it's solar photovoltaic cells, materials for the circular economy, biomaterials, there's enormous opportunity in New Zealand's tech sector for graduates in the sciences and engineering to make a real difference for New Zealand's economic, environmental future. So if you're interested in joining future industries that benefit New Zealand's economy and environment, come study with us at Te Herenga Waka, Victoria University of Wellington.